Hi everyone, this is the video for lesson 5.1 on the Pythagorean Theorem. So let's take a look. So the Pythagorean Theorem says that in a right triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the legs. So if we take a look at each side, this side of that triangle that's in there, this is a right angle, that side is 3, and then we made a square out of that side being 3 by 3. This side is 4, so we have a square that's 4 by 4. And then this side is 5, so a square that's 5 by 5. So if we count how many squares are over here, we end up with 16. So I colored them in on the other side. So if we take a look at the shorter side, we have 9 squares because 3 squared is 9. And if we look over there, there's 9 left. So we can see that if we square these two sides, it actually does equal the square of the bigger side. So I'm going to plug those numbers in to the formula to show that it works. So I'm going to call A being my side of 3. So 3 squared plus 4 squared is equal to the hypotenuse 5 squared. So we end up getting that 25 is equal to 25. So what we just did was showed proof that the Pythagorean theorem actually works. So a Pythagorean triple is any numbers that we can plug into the Pythagorean theorem and get out whole numbers. So they have to be positive and they have to come out as integers, which is whole numbers. So there's an infinite amount of numbers that actually work, but they get really big once you go past the first 10 or so. So the smallest set of Pythagorean triples is 3, 4, and 5. And those are the ones we just looked at. So if we plug these numbers in for A, B, and C, it always comes out to work, that it's always equal. Another set is 5, 12, and 13. And one more is 7, 24, and 25. So like I said, if you knew those two, you'll get 25 every time for the other one. And they always are going to be whole numbers. So let's take a look at our first example. So it says to identify the unknown side as a leg or a hypotenuse and solve for x. And to tell what's the Pythagorean triple. So then remember that means if it comes out to be perfect whole numbers. So we learned back in chapter 2 that the hypotenuse is a side that's across from the right angle. So that would be this side over here is our hypotenuse. And a hypotenuse is always labeled with C. So the other two have to be our legs. And it doesn't matter which we pick for A or B. It just matters that the hypotenuse is always your C. The biggest side is always on the C. So we can plug those into the Pythagorean theorem. So we'd have A squared plus 7 squared equals 25 squared. And then we can just solve this like a regular equation. So A squared, we would square numbers first. And then what would we do next to solve the equation? Very good. We would subtract 49. A squared equals 576. How do we get rid of the squared? Good. Take our square roots. So 576 happens to be a perfect square. So we get that A is equal to 24. So does that mean that those numbers are a Pythagorean triple? Very good. It does. There were our last ones that we wrote up there. Okay, so for number 2, if we look for our hypotenuse, that's across from the right angle. So this time we're missing C, and these are our A's and B's. So I'm going to plug those in for A and B. 8 squared plus 8 squared is equal to C squared. And then next we would square both numbers. So 64 plus 64 equals C squared. So this one's different because both of our numbers are on the same side, so we don't have to use inverse operations like we did here. So we would just add those together. 128 is equal to C squared. And then to get rid of the squared on the C, we take the square root. Is 128 a perfect square? Good, it is not. So you should do your factor tree and come up with all the factors of 128 to simplify your radical. So go ahead and pause and do that. Okay, so I hope you found that c would equal 8 root 2. So if you do not know how to find that, then ask me in class tomorrow. So is 8 and 8 root 2 a perfect Pythagorean triple? No, it is not. Because this is not a perfect whole number. Okay, so why don't you pause and try examples 3 and 4. Okay, so for question 3, I got 13. And for question 4, I got that side B, or that other side that's not the hypotenuse, is 2 root 10. Let's take a look at our example number 5. So this question is asking us something completely different. It says to find the area of the triangle. So if we remember our area of a triangle formula, it is that A is equal to 1/2 base times height. So if we take a look, remember the base, or the height, would be the one that goes from a vertex that is perpendicular to the other side. So this has to be our height. And then the base is the whole bottom part. So how big would our base be? Very good. If this piece is 2, then that piece will be 2 as well, because the vertex angle of an isosceles triangle theorem tells us that if we have an isosceles triangle and a line is perpendicular to the base, it'll bisect that bottom. So that means our whole base would be 4. So we know that when we plug in, we're going to have 1/2 times 4 times whatever our height is. But do we know our height right here? We do not. So how could we find it? If we know the bottom part, the hypotenuse, and we're just missing one side. Very good. We use the Pythagorean Theorem to find the missing side in a right triangle, and we know 2 of them. So our hypotenuse, remember, is the side across from the right angle. So this will be our C. And then it doesn't matter which one you plug in for A or B. So we have 2 squared plus, I'm going to use h since this is our height, equals 6 squared. And then we solve for h. Take our square root. Is 32 a perfect square? It is not. So if we simplify the radical, go ahead and make your factor tree. We end up with 4 root 2. You better make your factor trees. I want to see them. So we can take that height and plug it back in over here. 1/2 of 4 is 2. So we'd have 2 times 4 root 2. And then 2 times 4 is 8. So the area would equal 8 root 2, and our units were meters squared. Okay, good. So let's take a look at our converse of the Pythagorean theorem. So this tells us if we have 3 numbers, what kind of triangle they'll make. So remember back in chapter 2, we had the theorem that said, the triangle inequality theorem told us if the 3 numbers that we have are actually going to make a triangle, if 2 of them add to be bigger than the other side. Well, this one tells us if we know that they're a triangle, what kind of triangle they'll actually be. So if we take a look, we can go ahead and read them, but it says that if when you square them and make it equal to the biggest one, if they end up being equal, then it's going to be a right triangle. But if the a squared plus the b squared part is greater, it's going to be acute. And if the a squared plus b squared is less, it's going to be obtuse. Okay, so if we're plugging in 3 numbers, we always make c to be the biggest one, and then we just plug in the a and b in the other 2. And so whether they're going to be equal, greater, or less is going to tell us what kind of triangle we have. Okay, so let's try our first example. So the 9 is the c, biggest number is always c, and it doesn't matter which of these we plug in for a and b. I usually just do them in order, a being the smallest and c being the biggest. It doesn't really matter as long as c is the biggest. And I usually always write equals, but we're trying to figure out, are they actually equal, or is one side bigger than the other? So once we plug them in, we just do order of operations, square everything, and then we'll add these two together. So 49 plus 64 is 113. And is it equal to 81? It is not. Which one's bigger? Good, 113. So what did we say? If the a squared and b squared were bigger, then what kind of triangle is it going to be? Very good. It's going to be an acute triangle if a squared plus b squared is bigger. So pause and try the next two, please. Thank you. So for question number 2, I got that the c squared part was bigger, so that means we have an obtuse triangle. In question number 3, they were equal, because that's one of our Pythagorean triples, so it's a right triangle. Let's take a look at our last 2 examples. So these are word problems. So we need to draw a picture, just like we did in chapter 4, and then figure out what we're missing and how to find it. So for number 4, it says that we have a ladder leaning against a house. Here's my house. We have a 15-foot ladder leaning against the house. So in problems like this, when they talk about like houses or trees, you can assume that they make a right angle, even though not every side of a house or tree is going to make a right angle. You know, it might be slightly off. I mean, you want it to, but anyways, it says that the base of the ladder is placed 4 feet from the house. So if we look at it, we see that we have a right triangle in there. So we need to figure out where that 4 feet goes. Is it on the house or is it at the bottom? Well, since it says that it's placed 4 feet from the house, or from the base of the house, it's going to go down there at the bottom. So what they're looking for, rounded to the nearest tenth of a foot, is how far up the house does the ladder reach. So we would be looking for that side. And this would be helpful if you were trying to hang Christmas lights and you wanted to get them to the top. And if you know how far up the ladder is and where your roof is, you'd be able to figure out if your ladder is going to be tall enough. So if we plug those in, we know that 15 is going to be our C. It doesn't matter which one of these we plug in for A or B. And then use what we did for the examples 1 through 4 on the other side to solve and find X. So go ahead and pause. So I got that A is equal to the square root of 209, but they told us to round to the nearest tenth of a foot. So I ended up with that it would be 14.5. So that means that our ladder will reach 14.5 feet up the side of the house. So let's look at our last example and then we'll be finished. So it says that Jane and Zachary started walking at the same point, but Zachary walks 5 feet north, while Jane walks 75 feet east. Remember, east would be to the right if it's north, east, south, and west. So 75 feet. So if one's going north and the other one's going east, that means that they're going in perpendicular directions. So it'd be a right angle between them. So they want us to know to the nearest tenth of a foot how far apart they are when they stop. So that would be equivalent to that side. So how do you think you can solve and figure out how far apart they are? Very good. We're going to use the Pythagorean Theorem again. So remember what side gets plugged in for C. Go ahead and pause and set up your equation and solve. So when we set it up, we have 5 squared plus 75 squared equals x squared. And then we can do the math, and we get that C is equal to, well, I simplified my radical, but it's 5 root 226, which is approximately 75.2 feet. So thank you for watching. Werner out.